Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 30 to 34 of the June 2015 Algebra 1 Common Core Regents exam. All right, let's take a look at problem number 30. It reads, determine the smallest integer that makes negative 3x plus 7 minus 5x less than 15 true. Now, one thing you want to note when solving inequalities is that anytime you divide by a negative number, that causes the inequality symbol to flip to the opposite direction. So let's keep that in mind while we're solving this problem, okay? All right, so we have negative 3x plus 7 minus 5x is less than 15, okay? So what we're going to do is let's combine like terms. Let's combine negative 5x and negative 3x. Since they have the same sign, we're going to add and keep the sign. That yields negative 8x plus 7 is less than 15. Okay? The goal is to isolate x. So to get x by itself, we have to get rid of 7 first and then the negative 8. To get rid of 7, since we have plus 7 here, we'll subtract 7 from both sides. That's the opposite. So this adds up to 0. So we have negative 8x is less than 8. To get x by itself, we will have to undo this negative 8 that has been multiplied by x. So to undo our multiplication, we divide by negative 8. Okay, so divide both sides by negative 8. And that gives us x is what? 8 over negative 8 is negative 1. What's the inequality symbol going to be? Remember we talked about it earlier that whenever you divide by negative, it causes the inequality sign to flip. So this now becomes x is greater than negative 1. Okay? So any real number bigger than negative 1 will satisfy this inequality, But the question asks us for the smallest integer. Now, what is an integer? An integer are whole numbers and their opposites, including 0. So, for example, we have 0 is an integer, 1, negative 1, 2, negative 2, 3, negative 3. So all whole numbers and their opposites, including 0, are known as integers. So the question is, in the set of all integers, if we continue forever, which is the smallest one that satisfies this inequality here? To help us visualize it, let's graph the solution region on a number line. So x is any number that's greater than negative 1. So negative 1, open circle, and your arrow is going to be pointing to the right. Okay? So what are some integers that satisfy this inequality? Can we pick negative 1? The answer is no. Why not? Because you don't have a line in this inequality. You have an open circle, which means that negative 1 is excluded from the solution region. You cannot use negative 1. Okay? If it were a closed circle, guess what? That will be the answer. All right? So let's go ahead and list the integers that show up after negative 1. We have 0, and then we have 1, 2, 3. So out of all these integers, if we're going forever, which is the smallest one that fits that in this number line or this inequality? The answer is 0. 0 is the smallest integer that's bigger than negative 1. Okay, so let's write down what our answer is. The smallest integer that satisfies x being greater than negative 1 is x equals 0. That is our answer. All right, let's take a look at problem 31. It reads, the residual plots from two different sets of bivariate data are graphed below. Explain using evidence from graph A and graph B which graph indicates that the model for the data is a good fit. Okay, so what this question is asking you basically is which of these, graph A or B, is a bivariate data set? Okay, so in order to answer this question, we need to know what bivariate is. What is bivariate data? Okay, we can understand what bivariate data is by considering what is not bivariate. If something is not bivariate, is univariate. Okay. Now, there are so many ways you can look at bivariate and univariate data, but what's applicable to this problem is the whole idea of correlation. Okay. Bivariate data, the data measures have no relationship. No relationship. Okay? And univariate, they're related. Okay? Um, so since there's no relationship in bivariate data, this means that there is no correlation. All right? No correlation. In univariate data, guess what? There is correlation. So what on earth does correlation or no correlation mean? Well, the easiest way to look at it or to explain it is the whole idea of pattern. Okay? For no correlation, there is no pattern in the plots. But for univariate that's related or correlated, there's a discernible pattern in the plot. Okay? So all you want to do is look at these two graphs. Anyone that has a discernible pattern that has no correlation, that has correlation, that is univariate, and the one that's just all over the place is just scattered with no correlation, no discernible pattern, that is bivariate. Okay, so which one has a pattern here? You can clearly see that graph B has a pattern. Do you see the pattern? It starts low, it goes up, and then it starts to go down. Okay, so there's a story here, there's a relationship here. Okay, but look at graph A. The points are scattered all over the place. There is no discernible pattern. Okay, so which of these is univariate and which is bivariate? The one that's bivariate is the one with no pattern, graph A. This is bivariate, means that um, there is no relationship between the two different sets. And then this one, you can clearly see that there's a relationship. That's why there's a pattern here. So this is univariate. All right, so the question says which of these is a data for bivariate, is a graph for bivariate data? Your answer is graph A. Okay, so we cannot just circle graph A and say, okay, the answer is graph A. The problem asks us to do what? We're to explain. Okay, why do we know that graph A is a model for the data, is a good fit for a bivariate data? We have to explain why. Okay, so let's go ahead and explain why. So graph A, let's use uppercase. Graph A is a model for bivariate data. Bivariate data. Why? Because bivariate data has what? Bivariate data plots have no correlation. Okay? And graph A has no correlation or discernible pattern. Okay, if it's not positive negative correlation, but is there like a general pattern that can be seen here? Has no correlation or discernible pattern. Discernible pattern, unlike graph B, which has a relationship, or you can see relationship or pattern, okay? Because we talked about that earlier. If you look at the graph, for graph B, the pattern is it increases and then starts to decrease as a pattern, whereas graph A is just scattered all over the place. There's no discernible pattern or correlation there, okay? So this is the explanation as to why graph A is the model for a bivariate data set. All right, let's take a look at problem 32. It reads, a landscaper is creating a rectangular flower bed such that the width is half of the length. The area of the flower bed is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. So one tip is when you are solving algebraic problems involving geometric shapes that are not provided, it is always a good practice to give yourself a well-labeled visual, okay, so you can know how the different parts fit together in this problem. Now, in this problem, note one thing that's stated there. You were to write and solve the equation. Some of you are really smart. You can set up this equation mentally and solve it with your calculator. You will not earn full credit for that for this problem. This problem, you actually have to show all your work. You have to set up the equation and then solve it. Okay, you can't just skip steps and do stuff in your calculator and expect to get full credit. Now, first thing we're going to do following this tip here is to give ourselves a sketch of the geometric figure we're dealing with. And what is it? It is a rectangle, okay? We're dealing with a rectangle here. So we have a rectangular flower bed, so just sketch an arbitrary rectangle. Now, we know that we can call this the length, and that's the width of the rectangle. Now there's a special relationship in this problem between the width and the length. We're told that the width is half of the length. Width, W, is equal 1/2 of the length L. Okay, so what do we place for W? W is going to be 1/2 L. Now since W is dependent on L for its definition, we just leave L as L. Okay, area is length times width, which is 34 square feet. All right, now we have a nicely labeled diagram. Let's go ahead and write down the formula for the area of a rectangle, okay? So the area of a rectangle is what? Area of a rectangle is length times width, okay? A equals LW. Now, from this problem, we can see that A is 34. We're provided with that information. L is L, and W, the width, is half of L. All right? So we can substitute these values into this equation to find what the length is. Let's go ahead and do that. We substitute, we're going to have A equals length times width. And what is our length? Well, let's start with area. What is A? A is 34. What is L? Leave L alone. And W becomes 1/2 L. What just happened here? We just substituted the values of A, L, and 1/2 L for their respective values in this equation. Okay? So we have this equation. Now let's just simplify it. We have 34 equals 1/2 L times L is L squared. Okay, so this right here is part of the answer. What is this? This is the equation that must be solved to help you find the width. So this is the equation. All right. Okay, now we have part of the problem done. Now let's go ahead and solve the equation. Okay, solve the equation. Now, to solve the equation, we just have to get L by itself. So we can rewrite it as 1/2 L squared equals 34. Now, how do we get L by itself? This can be accomplished in two algebraic steps. Get rid of 1/2 first, and then the square. Okay? How do you get rid of a fraction? You multiply by the reciprocal. Reciprocal of 1/2 is 2 over 1 on both sides. Alright, so this divides out. And then you have L squared equals 34 times 2 is 68. Take the square root of both sides because the opposite of square is square root. So what do you get when you take the square root of the square of L? These ones cancel out, and then you have L equals the square root of 28. Let's go ahead and plug that into a calculator. So the square root of 28 is 8.2462. Okay, so let's write that down. 8.2462. So it's an approximation right here. So it's approximately 8.2462. All right, so is this our answer? Are we just going to round this to the nearest tenth and call it the answer? Absolutely not. You always want to make sure you're answering the question. The problem asked us to find what? The width. What is the width? W. So that's what we're looking for. What did we just find? We just found L. So how on earth are we to find W from L? Remember we have a relationship earlier that we stated? W is half of L, right? So let's go ahead and find W. Now since W is half of L, when we substitute L here, W must be 1/2 of 8.2462. Okay, don't round intermediate answers. You have to work till the end before you start rounding, okay? So please keep that in mind. So if you take 1/2 of that, just take 1/2 of every single digit. Half of 8 is 4, half of 2 is 1, half of 4 is 2, half of 6 is 3, and half of 2 is 1. Now we are asked to round to the 10th of a foot. This is the ones place, this is your 10th place. Alright, look at the number behind. It's less than 5, so we're going to just carry 0 and everything here becomes 0. So the width to the nearest 10th of a foot is 4.1 feet. So there goes our final answer. So don't forget, there are two answers here. The first answer is to set up the equation, which we did, and the second answer is to actually solve it for W and not L. All right, let's take a look at problem 33, the last one in this review installment. It reads, Albert says that the two systems of equations shown below have the same solutions. Determine and state whether you agree with Albert. Justify your answer. Okay? So in this problem, you're not just simply solving. You have to state if you agree or disagree with Albert, and of course, your work will be the justification as to why you agree or disagree with Albert. All right? So if a system of equations has a solution and another system has the same solutions, what does that mean? Well, that means that if you substitute the solutions you got from the first system, your answers, let's say you got 1, 2. If you substitute it into the two equations in the second system, you will end up with true statements. If you end up with false statements, when you plug in your answers from the first system into the second, then they do not have the same solutions. Okay? All right, so in this problem, we can solve the first, plug into the second, or solve the second and plug it into the first. We have a complication here. If you take a look at this one, it's you have to solve for y here first. Okay, that's the only one you have to solve for, and then you solve for x afterwards. For system 1, you can solve for x or y first. You don't have any restrictions as to what to solve. Okay, so I'll pick the first system. You can pick the second one if you want, but I feel the first one is easier to solve. Okay, so we have 8x plus 9y equals 48, and 12x plus 5y equals 21. I'm going to use the method of elimination here to solve this equation. So when we're solving a system using elimination, what we are trying to create are opposites, okay? We can choose to eliminate x or y, whichever we want. Let's go ahead and eliminate x's, okay? In order to eliminate the x's, we have to make the coefficients opposites of one another. This is 8 and this is 12. We need them to be opposites of one another. All right, so I need to find the LCD, the smallest number that these two go into evenly, and that will be the number that I want to convert both of them into. All right, so what is the LCD of 8 and 12? LCD of 8 and 12 is 24. Okay, let me rewrite that. LCD of 8 and 12 is 24. There are different ways you can figure this out. So 8, for example, what are the multiples of 8? 8 times 1 is 8. 8 times 2 is 16. 8 times 3, 24. 8 times 4 is 32. And what are the multiples of 12? 12. 12 times 2 is 24. Voila. There goes the smallest number that shows up in the multiples of these two. Our LCD is 24. Okay, so what do I want to do now? I want the coefficient of x in the first equation to be 24, and the coefficient of x in the second equation to be the opposite of 24, which is what? Negative 24. Okay, so equation 1, I will multiply it by, what do I multiply it by? Multiply it by a number that causes 8 to become 24. So 8 times what is 24? 3, right? Perfect. And then equation 2, what do I multiply by 12 to make it the opposite of 24? What do I multiply 12 by to get negative 24? The answer is negative 2. Okay? Now, when you're distributing here, you have to be careful to ensure that this number is distributed to every single term in this equation. The same applies to negative 2. Okay, so when we triple equation 1, the first equation, we have 24x plus 27y equals what? 48? No. You have to triple 48, which is 144. Now, negative 2 times this entire equation, that gives us negative 24x minus 10y equals what? Negative 42. So what have we just accomplished? What we've accomplished is we've been able to make the coefficient of the x's opposites of one another. So how is that useful? Well, if they're opposites and we combine them together, they add up to 0. Okay? So that's the beauty of opposites, because they get eliminated. So these two get eliminated to 0. And then we have 27 minus 10 is 17. 17y equals 144 minus 42 is 102. To get y isolated, you divide both sides by 17. And then when you do this quotient in your calculator, 102 divided by 17 is 6. All right, so there goes our y. Now let's find out what x is. And we can pick any equation we want. I would like to use the first one, so let's find x. Let's find x. So we know from the first equation that 8x plus 9y equals 48. So how do I find x from here? I'll simply substitute the value of y into this equation. So we have 8x plus 9y, which is 6. Okay, and then equals 48. Now let's solve this for x. So we have 8x plus 9 times 6 is 54 equals 48. To get x by itself, we'll get rid of 54 and then 8. Let's do 54 first. Subtract 54 from both sides. You get 8x equals 48 minus 54. It's negative 6, so you have negative 6, and then divide both sides by by 8 to get x isolated. So divide by 8, divide by 8. That gives us x equals negative 6 over 8. But these two have a common factor, right? The greatest common factor of 6 and 8 is 2. So divide top and bottom by 2. So your final answer for x is negative 3 over 4. So what have we found? What on earth is this? X equals negative 3 over 4 and y equals 6. What did we just find? This is a solution to the first system. Okay, so let's write that down. The solution to the first system is x equals negative 3 over 4 and y equals 6. Are we done? Absolutely not. Remember, Albert said that the first and second system have the same solution. So how do we know if this solution is a solution to the second system? All we simply do is we test it. Okay, we're going to test to see if this generates a true statement in the second system. Okay, so what we do is we test the second system with the solution, with the solutions. Okay, all right, now for the second system we have 8x plus 9y equals 48 and negative 8.5y equals negative 51. Now, do we have to test the first system? Absolutely not. Why not? Because it's exactly the first equation in the first system. Okay, so since the first equation in the second system matches the first equation in the first, there's no need to test. Okay, there is no need to test. It's automatically going to work. Okay, you can go ahead and try it out if you want, but it should work. Okay, so now we just have to focus on the second equation. Does it hold true for the second equation? All right, so we want to test the second equation. Test the second equation. Test the second equation. The second equation is negative 8.5y equals negative 51. So how do we test this? We'll plug in the value of y into this equation and see if we have a true or false statement. What did we get for our answer for y? Y was equal to 6, right? So since y is equal to 6, the question is, if we plug in 6 for y in this equation, do we have a true or false statement? Let's go ahead and do it. So we have negative 8.5 times 6. Is it equal to negative 51? We don't know yet. This is just a test. Let's go ahead and use our calculators to compute this statement and see if it's true or false. So we have negative 8.5 times 6. Answer, negative 51. Oh, excellent. It works perfectly. Negative 51 is equal to negative 51. Okay, which is a check. Now, let's say you don't like what I wrote up here. Okay, you don't believe me that it should work, and you say, you know what, I want to check for myself and see that the answer also applies to the first equation in the second system. So you can do a test just to satisfy your curiosity. 8 times what is y? Negative 3 over 4 plus 9 times y, just to show you that it works. If we get 48, then it's good, okay? 48, perfect. So you see that both equations are true. But this is unnecessary because we have an overlap between the first equation in the first system and the second system, okay? Now, do we agree or disagree with Albert? We agree because the solution to the first system satisfies the second system. Okay, so let's go ahead and write this. This is really important to get full credit. We agree with Albert. Why? Because the solution to the first system, what was the solution? X equals negative 3 over 4 and y equals 6 also satisfies the second system. Okay, so if you have a solution satisfying two systems, then you know that their solutions are in fact the same. There you have it. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. We'll appreciate your positive feedback. Don't forget to subscribe to our channel for instant updates to upcoming review series. If you have any questions on this problem, on this set of problems, or any questions on the Algebra Regents exam, just place your question in the comment section below and we'll be glad to address it as soon as possible. Don't forget to test yourself with our interactive practice tests on our website. Just click on this link to gain access there. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.